Yeah, so, okay. So today is September 11, 2020, and this is the monthly Longhorn Community meeting. And today we have a few things to talk about. Let me share my screen. The first thing is the upcoming Longhorn 1.1 release. And we are targeting to have the release by end of October or early November. And currently, we're also targeting the feature freeze for by the end of this month. So we can take a look at what's the current the features and the progress we have been made. So if you take a look at what is highlight features for this release, we do have a bunch of things listed here. So we have complete the node improvement handling, which is going to improve our node handling for the stateful set and allow users to automatically recover from the node failure of the stateful set parts. And also we're currently in the final phase of and verify the data locality option we have added for this release, as well as the replica eviction support and the rebuild support for the restoring volume and the DR volumes. So those features will already been done. So we are going to demo the data locality and replica eviction today as well. So on the other side, we almost have the CSS snapshot ready as well, so which we'll demo today as well. So we're also working on the permissive support, which is also very frequently requested features. And for the other features, we're still in the working on progress. All right. So the second thing we have in Canada here is, in fact, last week, about like half a month ago, we have joined the KubeCon EU 2020, and we have sent out a survey for the Kubernetes persistent storage status, and we are going to send out the result of the survey very soon. And now we can have a list of the what data we have get from the survey. So, well, sorry, let me stop sharing for now. I need to log into this. Give me a moment. All right. So in fact, you can see that we got about 290, 300 responses, and there's still a bunch of responders doesn't have Kubernetes cluster, even like this is KubeCon, right? But for the most people, they are using like node, have like from 5 to 50 nodes. That's become the most majority of people. But we do see a response with more than 100 nodes. There's like 19 response have that. And also, we can see that for the part of persistent storage is the part we especially like cares about. And you can see, in fact, supermajority basically means that yes or no for this you use persistent storage option with the Kubernetes, and those is basically takes the most part of the responders. So only a very small numbers of responders saying that they are not going to, they don't have plan to use persistent storage with Kubernetes, or and also we have some insight here. So when I ask what's your current storage solution for your Kubernetes cluster, we can see that in fact for the almost half of the responders saying that they are using the cloud provider solutions. Right, but in fact, this is the multi-choice, so maybe the number gets been skewed a little bit. But also, we can see that the open source solution, as which is the red here, and also the dedicated storage solution, which is like EMC NetApp, takes the majority of the chunk of the others, unlike other pies. And the proprietary SDS solutions doesn't really fare well in this survey at this moment. All right, so. Another one I want to point out is what's the use case for persistent storage with your company? The supermajority, in fact, as most people answer this question with the like it's the database, right? And then after that, it's Elasticsearch Object Store and Fast Server, right? So this we can identify those as the most common workload we're going to target. for the persistent storage with using the Kubernetes. All right. This survey result is not that encouraging, but also means that there's a lot of room to improve. The question about have you used the Longhorn before? In fact, the supermajority of the users haven't used Longhorn before. But for the experience that people are using Longhorn, and we have some options to say which one, what do you like about Longhorn, right? So we do see that easy of use, one-click installation, which is basically on the user experience side, and in fact, it's taking the highest mark here. And on the other hand, that's because of Longhorn's community-based project and the highly available nature of Longhorn, also and also no need for very complex surrounding network, and those take a very high mark as well. So this is and also we are still diving into the more details and the users' feedback, and for example, what's the feedback saying if you don't use Longhorn now but used it before, why you stop using it? And I think some of them I like switch creator, but the others indeed have very good feedback for us to improve. And also what's the enhancement we want to see in general, and like in Longhorn Kubernetes, we are also going to dive more into those in the formal survey report coming out in the following weeks. All right, so okay, so that's for my part. So for the next part, we are going to show the demo of our the new features in the Longhorn 1.1 release. So today we scheduled the 3 items: replica eviction support, data locality, and the CSI snapshotter. So let's go with the replica eviction support first. So Bo, who is the main engineer for this feature, will show the demo.
Yeah, sure. Let me share my screen. So right now I have deployed a cluster with 4 nodes, and then first of all for data for the disk eviction, it's basically you have like multiple disks, and then you have replica on the disk of nodes, and then you can do like only one click to evict the replica to the other node and disk, and then this will help user to very easy to remove to maintain a disk or a node. So the use case I'm going to show is like, let's say I'm a user and then I want to maintain a node, and then I try to evict all the replica and then the pods like on this node, and then I may do the maintain and then like install new package and then reboot the nodes. So first of all, let me create a volume with 3 replicas, and then I'll attach it to one of the node, and then we can see, okay, right now this volume has I'm sorry, I should do this one. Yeah. So I think this one is better. So let's say I have a deployment demo, and then in the deployment I deployed a pod, a container Nginx, and then it's using our Longhorn the persistent volume claim using our Longhorn provisioner to create a volume and then attach to this pod, and then so let me do this.
Yeah, so what's the difference? So the difference between the previously we showed the volume there is because that one is created through the UI, right? So it's it's not also really associated with any workload or Kubernetes.
Yeah.
So this use case, in fact, is real, right?
Yes. So here we see yeah, so we can see right now the pod is running on node 4, right? So right now, let's say I want to maintain node 4. So I can, first of all, from here, I can select eviction request true and then disable this node. And then from here, you will expect the replica number will goes to 0, and then it will try to build one replica to the other node. And then, yeah, from here you see, okay, the replica got evicted. And then here we can do the to drain this node, and then to see the pod which we deployed here will move to the other node. And then after this we can maintain this node or reboot this node without any interruption, without any impact to our cluster. And, yeah, and then this may take a while to. And now we can see, okay, this has been cordoned, and then also we can see a node is being created on other a pod is being created on other node, and then once it's success, then this will take some time. And then once it's done, then we can say, okay, this node has been successfully evicted the replicas, and then has been successfully been drained, and then we can
so that we can perform the maintenance on this node.
So we can, and then we can check this later.
Okay. All right, so next I'm going to give demo on the data locality. So Fan.
Yes, so hi everybody, I will share my screen. And first, let me quickly go over what is a high level overview of the data locality feature. So as you already know, a Longhorn volume contains two components, an engine and one or many replicas. And the engine is a process running on the same node as a consuming pod. And as you see on the picture on the left side here, and the replicas, which is a component which holds the actual data of the volume. And the replica can be on the same node, can be on the different node. It doesn't have to be on the same node as a consuming pod and the engine. And before we have the data locality feature, or if the user choose to disable the data locality feature, as you can see on the picture on the left side, Longhorn may schedule the replica of the volume, the replica number 1 and the replica number 2 on two different nodes, like than the consuming pod. So as in the picture on the left side over here, we don't have any replica on the same node at the consuming pod. Like after we have the data locality feature, user have the option to turn it on. And when the user turn it on, the idea is that Longhorn will try to keep a local replica on the same node as the running engine and the consuming pod. So that is the overall idea of the data locality feature. So in enough theory, let me go ahead and jump into demo. So for the demo, today I plan to have two demos. The first one is just a simple deployment to demonstrate the idea of the data locality feature. So I will create a deployment of one pod using Longhorn volume, and I will show that what will happen when we turn on the data locality and what will happen when we turn off the data locality. With that in mind, let me quickly go over the cluster. So I already installed Longhorn with the master image. Yeah, you can see over here all the like Longhorn Manager and Longhorn Engine are on the master image. I will go back. So this one is a storage namespace. I know the storage project. It is which is a concept in Rancher represent namespace. I will go to the default project and then deploy the deployment over there. So I can, from the UI, I can click deploy, and then I will create a deployment, a cell, I will name it cell locality off. So this deployment will have the data locality off. This deployment using, I will create a volume for this one. I will create a new persistent volume claim. And then on the storage class, I will use a Longhorn data locality off storage class. So like how do I get this one? This storage class is I deployed this storage class before this demo, and let me show you quickly what do we have inside the storage class. Let me launch the kube control command over here, and if we get all the storage class, we can see that we have 3 storage class over inside the cluster right now. The first one is a default. The second one is a storage class with the data locality turned off. The third one is a storage class with the data locality turned on. Let me quickly show you what we have inside the data locality off storage class. So you can see that on the parameter field, on the parameter section, we have the data locality set to disable. So this storage class will instruct Longhorn like not instruct Longhorn that it doesn't have to keep a local replica on the same nodes as a volume. And if we take a look at the second storage class, which I prepared before the demo today, the data locality on storage class. This storage class has a data locality parameter set to best effort. Best effort means Longhorn will try to keep the one local replica on the same nodes as a volume, as a running consuming pod. So with that in mind, I will go back to the deployment. For this deployment, I will choose the data locality of storage class, and the name for this PVC, we can name it data locality of capacity, let's say 2 GB. Define that and mount to the mount path on the container, mount directory on the container, and hit launch. You can see on the left side, there is a volume, there is a newly created volume, and it is attaching to the node. If we take a look at the detail about the deployment, we see that the pod is attaching to the worker node number 1. And if we take a look at inside the volume, we have the replica is scheduled to the worker node number 2. So in this case, the replica is on the worker number 2, but the pod and the engine is running on the worker number 1. So they are on 2 separate nodes. There is no local replica in this case. So that is for the deployment with the data locality off. Now let me quickly deploy another deployment with the data locality on. And this one, I will choose a new persistent volume claim for this one, and the name of the persistent volume claim will be data locality on PVC. So storage class is data locality on, and let me give it 2 GB. And the mount path gonna be NT launch. we see that there's a newly created volume on the right side. The volume is attaching to the worker number 1. The replica stay on the worker number 1. So as you can see, when we turn on the data locality, Longhorn will try to keep a local replica on the same node as the running consuming pod. Now let me prove to you that this one is not happened by chance. This one is not by lucky. Yeah, and let me prove that Longhorn actually did something to make this it happen. In order to prove that, I will quickly modify the YAML file for this deployment and force this deployment to be scheduled onto a different node than the worker number 1. And because we turn on the data locality, I hope that Longhorn will move the replica to the new node on the same node as the pod. Let me quickly modify the YAML file for this deployment to force it to be scheduled on the worker number 3. We can use a node selector to do that. We can modify the template YAML file and then add a node selector. Maybe we have to add it inside the spec. And we save it. Let me scale down this one to 0 to detach a volume. Why is it still attached? Yeah, it is detaching, and now the volume is detached. I can scale up the volume, scale up the deployment, sorry. You can see that the pod is scheduled on the worker node number 3 by Kuber's schedule. And on the right side, you can see that Longhorn migrating a new replica on the worker node number 3. So now we are back to have the data locality feature. We are back to have the data locality. We have replica is running on worker number 3, and the pod is also running in the worker number 3. So that concludes my first demo about a simple deployment which used Longhorn storage class to turn on and turn off the data locality feature. So that is just a toy demo. Let me move on to a more practical demo, which is a database application. So the idea is that, like, in many cases, as you can see on the surveys that we just got from the EU KubeCon, like one of the most used case for Longhorn is a database application. And in many cases, database already the user application is already able to do the replication, and it doesn't need Longhorn to do the replication. So for example, a database application can create like 3 pods running on 3 different nodes, but the 3 pods manage the same data sets. So the database application is able to do the replication itself. It doesn't need Longhorn user doesn't need Longhorn to do the replications. And each pod gonna have each pod gonna request 1 volume from Longhorn, and from the application perspective, the application know that in order to achieve HA, it has to schedule the pod onto different nodes. But when the pod requests the volume from Longhorn, Longhorn doesn't know that those pods are on this. Longhorn has no idea that the pod manage the same data set. So it could be the case that Longhorn will schedule all the volume of the pod on the same node, or it could be the case that the Longhorn schedule some volume, like 2 volume of two ports on the same node and one volume of the other port on a different node. And it could be the case that Longhorn spread the volume on each volume on a different node. And we are like not sure about that decision. So from my calculation, the case, the situation on the left side could happen like 11%. If everything is randomly, then the situation on the left side has 11% chance to happen, and the case that all the volume, like each volume is on a different node, is about 22%, and the case that we have two volume on the same node and one volume on a different node is 66%. So the idea is that Longhorn doesn't have any idea. Longhorn doesn't know that those three ports as the port as a replication part of the database, and they manage the same data. So Longhorn doesn't know that. So it could be the case that Longhorn schedule all the volume onto the same node. And now the problem is, what if the node 3 go down, then we lose all the volume, like 1, 2, 3, and it destroys the replication purpose of the database application. So that is the situation when we have the data locality turned off, or we don't have data locality feature. On the right side, when we turn on the data locality, Longhorn, we try to keep the volume of the port on the same node as a running port. As a result, we see that like we have 3 volumes separate onto 3 different nodes. And now if node 1 go down, we lose volume 1, but we still have volume 2, and volume 3 contains the same data set. So it should be fine. So that is a theory. Before I jump to demo, is there any question for me at this moment? I think you are mute.
No.
Yes. Hi.
Do you hear me?
Yeah, I can hear you now.
Thank you. May it can be the case in...
Sorry, your volume is very loud. Your microphone is boosted.
Yeah, I think we lost you again.
Is it better?
Oh,
Yeah,
yeah.
now it's good. Thank you.
Oh, thank you. Thank you. I think it can be the case if you use a database such as Cassandra, but in case of using database such as Postgre or MySQL, replica won't be on the same node because your database will use a Longhorn replica, not I can imagine that database put all their data on the same node.
Okay, I think I can explain this. So if you have a database that only have, for example, just traditional MySQL, right? Traditional MySQL only need 1 disk. And so basically you're going to translate it in the concept of like 1 volume inside Longhorn. And that volume going to have 3 replicas by default. And that 3 replicas are going to spread across different nodes by default, right? So that is what Longhorn designed for. So here, this case, we have this database. In fact, this can be scaled like horizontally. So you can add more instance of database, and this database is like have the ability to do the replication by itself, right? So it's not necessary to depend on Longhorn to do the replication for it. So in this case, the choice you have is to configure the replication of the Longhorn to be only one because you already know that your data is pretty much protected by the application level, and the redundancy of the data has been proved, be ensured, right? And also you can still take the advantage of snapshot and also the data flexibility of the Longhorn and the backup mechanism of Longhorn.
Yes, but it's for this reason that I think that on your slide, you should not that it's for database who doesn't have their own who has their own replication.
Yeah, so sometimes you don't really have a control over that, because for example, if the database they decide to be okay, I want to run this as a sharding, or I want to have the striping mechanism things, and also they say, okay, so if I don't run this way, I have to have 1 terabyte disk or 10 terabyte disk, because if they want to have that, they have to have data equity in one place, right? So in fact, if you are saying you cannot do that application, then you lost the flexibility for the user to really configure that freely to the best to their needs. So that's why in this case, if the user want to have one replica but multiple application level paths to drive those replicas instead of Longhorn to do the replication, user can still take advantage of the highly available of the Longhorn, because with the data locality feature, we are going to ensure that since you have multiple workload for the same service, right? So you are going to have soft and anti-affinity rules against them to make sure they are not on the same node. Otherwise, that node goes down, your service go down, right? So Longhorn is going with that. Longhorn can use the data locality, also ensure that so the data of this workload is always going to be the same node as that. So whenever one node goes down, it's not going to have the situation that what happens to the node 3 in the left diagram.
I've got a little problem with this kind of concept of data locality when it's on, because, for example, on my cluster, I dedicate 3 nodes to persistent who have a big disk, and I put a tenter on these 3 nodes.
Okay.
To only have Longhorn on this.
Yeah.
So I can't use data locality is on.
You cannot use it. Yeah.
So I must have locality is off.
Yeah.
I don't know how to use it in this case.
Yeah. So this data locality case is designed to have the store only for the case that have the storage mixed with the workload, right? So that's mostly the hyperconverged stuff. But if you have a dedicated storage, for the Longhorn or for any storage solution there, and you have big disk for that and the power CPU for that, yeah. So data locality is not going to be applicable in your case. Yes, then you better have the application to say, okay, I will handle Longhorn to do the replication rather than application do it itself. In fact, in that case, yeah, might be there's something more we can do about that to ensure that the data will not going to be stored in the one node, but then we need to introduce some application workload awareness, more than the data locality in that case.
Yeah. Maybe we can add some parameter on PVC to say that the replica mustn't be on the same node, even this doesn't belong to the same PVC. I don't know how to express that, but
yeah, but if I understand you correctly, you have dedicated storage nodes, right? Where you don't actually run any workloads. You just use Longhorn to provide storage from these nodes to the rest of your workload nodes. So in that case, you don't actually need data locality, and you don't need to be concerned with it. We wouldn't be scheduling it as long as you have it set up via the taints anyway.
Yeah, but for example, if you take the first on the, I don't know if I can point. No, on the left slide.
Yeah.
You can just imagine that we have a node 4 who doesn't belong to the to the part of the cluster.
Mm-hmm.
And if I've got that, I'm not able to say that my Cassandra database
Mm-hmm.
won't have all replica on the same nodes like it's the case here.
Oh no, that is for that feature we have like anti-affinity. So what you want is hard anti-affinity, which we have to set as default for Longhorn 1.1, but we are going to change that back to soft anti-affinity. That will guarantee that no replica of your workloads are on the same node. Is that your concern?
I think it's probably slightly different because the case here is the anti-affinity works when we have multiple replicas for one volume, right? So we know they belong to the one volume. But if you have the case like here, so there are multiple replicas, but each workload only have one replica. So there's for now, the Longhorn doesn't have a way to know that, well, those workloads are in fact associated. I should separate them as much as possible for the replica, right? Is that your question?
Yeah.
Yeah. So in the case of data locality, and we can solve it, but without the data locality, we still ideally we still want to have those like replicas spread across whatever available storage node rather than like aggregating one storage node in case that node went down, right? So that is something we haven't solved right now. So what I can think about is we can, for each on the scheduling part, we might also take a look at what the workload is using it and where the workload has been scheduled and to see if there's any like relationship, and we need to have some logic to discover that before we we can decide where to put the replica. So that's so if you want, you can find GitHub issues and the features. We can track that. I was think that is pretty reasonable use case if you have like one replicas for the application level replication.
Okay. Thanks.
All right.
Thank you. So before I jump to the demo, I just want to add one more point, which is another benefit of the data locality feature is, as you can see on this picture, it decreases the network load a lot. So on the picture on the left side, we have the port 1, when it read or write data, it has to go through network to the node 3, and same for the port number 2. But on the picture on the right side, there's no network load. Everything is local. And now let's jump to the demo. I will go back to the default project, and I go to application, and I will launch AWS MariaDB and create. I will launch the MariaDB application, and inside this, inside the setting for the MariaDB, we are gonna change 3 things. The first one is the namespace. Let me name this one to be a different namespace, maybe number 4. And then I will change the replica count. So as you can see that this application is able to do the replication itself. It doesn't need Longhorn, the user doesn't need Longhorn to create like multiple replica for the same PVC. This one already has the replication capability. And then I will choose a persistent volume for the slave server. Slave server mean like just today I look up the information for this database application. Basically, the model for this database application is we have the master and we have slave. The slave is the replication of the master. So with the setting replica count to 3, we're gonna have 3 slaves which contain the same data as the master server. And MariaDB gonna try to schedule the 3 slaves on 3 nodes, on 3 different nodes. And then for the storage class, I'm gonna choose the Longhorn data locality on storage class. And that's it. I changed 3 settings. The first one is namespace. The second one is replica count. And the third one is I choose to use persistent volume with Longhorn data locality on storage class. And I launch. So as you can see over here, we have one master server. We can call it one master pod. And we have 3 slaves server, which is 3 slave pod, which contains the same data as a master's pod, but they're gonna be on 3 different nodes. I guess the MariaDB used some type of pod and type affinity to schedule the pod on 3 nodes. Let me quickly delete all the previous demo so that we have a clean view of this on the storage side. So let me quickly delete those 2 deployments. On the right side, we see that the volume is the volume associated with those old deployments was detached, and then I will delete those volumes.
Okay, it's better to do the deletion from the PVC and the PV, then they're going to be deleted automatically. Now it's kind of become unbound.
I see. So you can see on the right side, we have the slave 0 pod is up, and not up, but it's created a volume on the right side. And on the left side, we see that's a slave pod number. Slave pod 0 is running on the worker number 1. If we take a look at the replica of the volume, we see that the replica is also running on the worker node number 1. This application is takes some
time. Can you check why this application is not up yet?
I'm sorry?
Can you check why this application is not up yet?
I think that this one take a little bit long to start.
Yeah. Okay, so anything happens in the event?
I think that I got into the issue that when we reuse the namespace name for this application, I always get into the same error, which is the
I guess what happens is yeah, can you check the PVC for this namespace?
Yes. Default, and then
just resource workload volume.
Oh, I see.
Yes, so this one persistent volume, this should be fine, in fact. All right, so well, so this is live demo, so something happens. Well, let's check back later. And all right, so in fact, we're a little bit running out of the time right now. So Joshua, how long do you think you need for the CSI snapshot?
No, I should be good. I can do the live demo. Yeah, I should be fine.
Yeah, I mean, how long you need? Because now we're like 5 minutes past.
Oh, I can adjust. Like I can make it really quickly. Just give a quick overview. Yeah, I can give a 5-minute overview. Okay, let's do that. 1 second. Screen 2 begin. All right, can you see my screen?
Yes.
So there will be documentation as a prerequisite. You need to deploy the CIDs and the snapshot controller to your clusters, and the documentation will be mentioning that. So definitely check into the documentation before using it. Now, so the idea here is to be able to interact with the Longhorn backups via programmatically. We want to use the CSI mechanism of the volume snapshots. So Kubernetes added the new volume snapshot CID. I already have one for the test volume. And if we look at the volume snapshot content that is associated with it, we can see.
Sorry, Joshua, let me give you some context here. So this feature is called the CSI snapshotter, and why we're doing this is this provides another way for the user to programmatically create and restore snapshot. In fact, it's going to be the backup inside Longhorn. So now with this feature, you don't need to go to the Longhorn UI to do the create backup and the restore backup operations. You can do it all from the command line using the kube control. So this is thanks to the snapshot part of the CSI spec. So here we are showing that how we can do it from the using the kube control on the command line instead of that traditional way of you all have to do it through the Longhorn UI. All right.
Yes, and what this also enables you to do is if you're using any like operators that end up handling your backups and stuff or custom development, then you will be able to use that via the CSI interface to interact with our Longhorn backups. All right, so I'm making this really quickly. I'm gonna start with a clean slate. I'm gonna remove the volume snapshot that I currently have. Let's test, and then we can have a look. All right, so this will delete the volume snapshot for the test volume. The test volume, here's the previous CSI snapshot. We can delete them as well. And that delete operation will end up removing all the backups for the volume. As you can see, the volume has no backups at this moment. So now we have no backups for the volume, and we want to, let's say we want to create our snapshot. I have provided like some example YAMLs. We can have a quick look at what they look like. Let's say we want to snapshot our test volume. And they're very easy. You just define the volume snapshot class name, and we provide a default one, Longhorn, with a default deletion policy of delete, which will, if you delete the volume snapshot resource, we will also end up removing the backup from the backup store. So how to use this? You just use regular kubectl commands like create for creation of this resource. Now, once this resource has been picked up by the CSI snapshotter, that will initiate a snapshot on the Longhorn side. Loading, loading. Loading, loading, loading. Create snapshot, created snapshot, drive up to snapshot status. Start it. That looks good. We have created a snapshot, and the snapshot completed. As we can see, it's there now, 5 seconds later. So, and this snapshot will also have been backed up. And as you can see with the backup information here, the regular Longhorn, if you're familiar with the regular Longhorn backups, it's the same process. So we can verify that by just going to the test volume. And that's the backup ID. That backup is identical to like a Longhorn backup. So you should be familiar with like the restore, delete operations, etc. You can do a manual restore of this, but you can also use the CSI snapshot feature, which is also new. Let's go there right quick to restore this volume. And that works via a regular PVC definition, except that you specify a data source that points to our previously created volume snapshot. And you can verify this by, since we only have one, this is the same name as here. The data source will point to this one. And the ready-to-use field is very important because the ready-to-use field defines whether the backup has been made available to the backup store. Let's say initially since we have a O1 operation for the volume snapshots, that goes really fast. It doesn't take any time. But depending on the size of your volume, it might take a couple hours if your volume is a couple gigabytes to transfer all the data to the backup store. And during that time, the ready-to-use field will be false. But as soon as the backup is done, the ready-to-use field will be true. So if you're writing an operator, for example, to interact with these backups, you want to query that ready-to-use field and evaluate that. Okay, so let's say we want to do a restore of this. We can just deploy the above persistent volume claim that will trigger a restore. And this restore mechanism will, as you can see, it's already done it's already in the process of doing it. It uses the same mechanism that, if you're familiar with it, previously we provided the ability to do restores via a storage class. And this restore operation via the CSI interface uses the same mechanism as the storage class restore. So that volume has been restored, is all ready to use. We're good to go. And there's one more thing that's that to show like how you can delete backups. Let's say you want to clean up. Let's say you want to run your unit test or something. You have specific workloads that you want to do backups and unit test that, or do like crash tests on your cluster. So you can write a little operator that deals with via the CSI interface with the Longhorn backups to do these tests. Okay, so to delete this is also same process. We can just kubectl delete the associated volume snapshot. Since the deletion policy is set to delete, this will remove the underlying backup from the backup store. Okay, we can query this, and that's gone. That's gone. There's one last test, which is how can I use, let's say I have already been using Longhorn for a while, and I have a bunch of backups already. How can I use them? How can I expose them to the CSI interface? I'm going to go quickly because we're out of time, but basically the way you do this, you will have to define a volume snapshot content object where you set the source to a Longhorn snapshot, and the format is the snapshot handle. This will change in a future version, but for now we're pointing directly to the backup store. The format is snapshot handle BS for schema, the volume backup volume name, and the backup name. Once you created that, you can also again use kubectl for this. kubectl create. Oops. After you created the volume snapshot object, you will want to create the associated snapshot. And as you can see here, the difference, this one points via the source object to the volume snapshot object. So kubectl. So now we have the backup has been exposed, basically. Now we would be able to restore this backup, like the same process we used previously for the PVC, just by pointing the PVC to the volume snapshot that we created for it. Okay, And as you can see, this looks the same as the other PVC, except we're pointing to a different snapshot. And yes, normally you could restore this right now, except I made a mistake. I forgot to update the snapshot handler, so I'm pointing to a non-existing backup for the demo. So that's all for me, from my side. Is there any questions? Good. Yes, very quick.
All right. So any questions for in general for the Longhorn and other things you want to discuss?
Oh, can I share my screen with that to show like
Yes.
the?
Sorry. Let me. How do I?
To show the dream success and then.
Okay.
Yeah.
I hope it didn't take so long.
No, it's like finished pretty soon. You see, right now this. Yeah, right now this move to node 1.
Yeah, I see on the right side. It's in fact, it's the time it takes longer than I expected. We might want to see it. So might be some. Oh, I think it's probably that multi-attaches like timeout stuff. Yeah.
Yeah, but yeah, this successfully work. Yeah, that's all from my side. Thank you.
Can I also have 10 seconds to show that the database up running?
Yeah,
and
sure.
I think that I found the problem. The problem is, the problem that the previous demo failed because we use the same name for the database. So when I name it to a different one, everything worked fine. So we can see M3. And if you take a look at the location, the replica, we have one replica on the book number 2, another one on the book number 3.
Yeah, I think reusing the name and the
so
PVC name is really the most common reason for sometimes storage doesn't work.
Yeah, and another one for the Google number 1. And of course, this one is not happened by chance because the probability that we get this one is only by randomly is only 22%. So this one's Longhorn does something about it.
All right. Okay. Any other questions for Longhorn? All right. So thank everyone. Thanks for the demo, and thank everyone for attending. And I will see you next. Yeah. See you next week.
Thank you, guys.
Thank you.